Hello everyone, this is Dr. Lennon, and in this video I just want to give an overview of interval notation, which is another way to write down the solution set of an inequality. It basically specifies some interval of numbers. So one way to think about this is kind of like bookend notation. So the main idea is we have like some symbols and we do either kind of like the smallest number and then the biggest number, and we need a way to determine whether or not those numbers are included in our interval. So let's just go through some examples and you'll quickly see how this works. So let's just say describe each interval using describe each set maybe using interval notation. And it's really just another way to describe the solution set to an inequality. But it's a little more efficient and brief than drawing a graph or maybe writing down some specific variable. So let's say A, maybe we have something like 3x is less than or equal to 15. Well, you would solve this first. We divide by 3 and we'd have something like x is less than or equal to 5. And then once we've solved it, you can kind of compare it to the graph. So if your graph is down here, you have the number 5, and we would shade that, and then we'd shade to the left. So in this case, there's no smallest number. So when there's no smallest number, we would use something like to the left, it's pointing toward negative infinity. So it's continuing without bound to the left. So we use the negative and then the infinity symbol, and then we do a comma, and then 5 is the biggest number. So if we want to include the number, we use a square bracket. If you don't want to include the number, you use a parentheses. And a parenthesis is always used with an infinity symbol. So keep that in mind. We could also have something like, let's say 4 is less than or equal to x is less than 11. So if you would graph that, this is a compound inequality. We would have our 4, we would have our 11, we would shade the 4, we would have an open dot on the 11, and then we would shade in between. So on the interval notation, our smallest numbers are 4, our biggest number here is our 11. We want to include the 4, so that gets a square bracket. And we want to just use 11 as a boundary. We don't want to include it, so that gets the rounded grouping symbol. So you'll kind of notice including the number corresponds to a square bracket, a shaded dot, and an underline with the inequality symbol, either less than or greater than. And that's essentially the hang of it. There's really not much besides that. Let's do a few more just for practice. Let's say something like 10x plus 2 greater than 42. Okay, so we would solve this inequality by subtracting 2. So we'd have 10x bigger than 40. Then we would divide by 10. So we end up with x is greater than 4. And so that graph looks like this, where we have a 4, an open dot. We're shading the numbers bigger than 4, so that's to the right. So here our smallest number is 4. It's an open dot, so it's just a boundary, so it gets a rounded parenthesis. And then it's going without bound to the right, so that's going to be an infinity symbol. And then the infinity symbols always get those parentheses. Let's talk about, suppose we have two things that are disjoined. So maybe we have, one of those, let's say quadratic type inequalities. Let's say we have, x plus 2 and x minus 3, and this is, say, greater than 0. Well, remember, this would amount to setting up the test value regions -2, 3, and we have 1, 2, and 3, and we would want to test those regions. So you can refer back to the solving inequality symbol. video to check that. But I will tell you that the solutions that are going to be the solution to this one is basically going to be -2 this way and greater than 3. So we've got two disjoined intervals that are both part of our solution set. So basically our solution set is x less than -2 and also x greater than 3. You can just plug in some numbers to check that's true. So how would we write this in interval notation? Well, this part is -∞ to -2, not including the -2, and then we have the 3 all the way up to infinity. And then if you have two disconnected ones that are both part of the solution set, you connect them using an upside down U like that, or a right side up U. So it looks just like a capital U. That's the union symbol. So the U is the union symbol. So this connects disjoined parts of a solution set. In our interval notation. Okay, so let's see how to enter that on WebAssign, just to make sure we're doing it right. So let's just look at this one. 2x greater than or equal to 10, that's going to have solution x greater than or equal to 5. So if we were graphing that, right, we'd want a closed circle on 5, and then we want the numbers that are bigger than that. So 5, and then we want to shade to the right of that. So I'm not exactly sure how to do that. But so let's see. On here, our solution set would be a square bracket with a 5, and then we would want to go up to infinity. So we find the infinity probably under symbols, and there it is, 5 to infinity. But we don't want to bracket. Like I said, we want to open parentheses, and then we have the correct thing here. We just need to make sure that we're shading it to the right. So how do you shade here? Draw, maybe that. Draw. Yeah, and then we've shaded to the right. So that looks like it should work. Let's go ahead and check this one. So I'm just going to go ahead and submit the whole thing to see if we got the interval solution part correct. So let's just go down to the one that we did there. Yeah, so we got the 2x greater than 10, so from 5 to infinity, and then we also got the graph correct. So the check marks by each. So that should clear things up if you have any problem with the interval notation. This is Dr. Lennon signing off.